You have a million documents and an AI. You have two choices: teach the model or show it the answer. This is the difference between fine-tuning and RAG. Every enterprise wants to customize large language models with their data. But here's the question: should enterprises teach the model new knowledge or give it access to external information? This is the fundamental choice between fine-tuning and RAG, retrieval augmented generation. And in 2025, the answer isn't one or the other, it's understanding when to use each. Let's break down how these approaches actually work, what's changed in the last year, and how to choose the right strategy for different use cases. RAG is like giving an AI an open book exam. The model doesn't need to memorize everything. It looks up relevant information when needed. Here's how it works. When a question is asked, the system first searches a document database for relevant information. The most relevant text chunks are then passed to the language model as context. Finally, the model generates an answer grounded in what it just retrieved. The key advantage? The knowledge base can be updated in real time without retraining the model. Add a new document and it's immediately searchable. Update a policy and the next query reflects it. This makes RAG ideal for dynamic information. Think customer support documentation, legal databases, or company wikis where information changes frequently. But here's the trade-off. RAG doesn't help with style consistency. It retrieves facts, but it won't make the model write like your brand or follow specific formatting rules. 2024 and 2025 brought major improvements to RAG systems. The old retrieve and hope approach has been replaced with sophisticated retrieval pipelines. First, the retrieval foundation got stronger. Hybrid search combines keyword precision with semantic understanding. Query rewriting uses small language models to rephrase vague questions. Production systems show 15 to 25% recall improvements. And cross-encoder re-ranking from providers like Cohere ensures the most relevant documents surface first, boosting accuracy by over 20%. But the real breakthrough is Agentic RAG. Instead of retrieving once and generating, these systems plan, search, validate, and repeat. 4 patterns define this evolution. Reflection: the system critiques its own output and tries again. Planning: breaking complex queries into multi-step searches. Tool use: dynamically selecting which databases or APIs to query. And multi-agent collaboration: specialized agents working together as a team. Deutsche Bank's DB Lumina uses this approach. 10,000 analysts accessing earnings reports 30 to 45 minutes faster. Morgan Stanley's system achieved 98% adoption across financial advisor teams. These aren't prototypes, they're production systems handling real enterprise workloads. And there's GraphRAG, an approach to multi-hop reasoning over knowledge graphs. It excels at questions like, who managed the team that built this product in 2024, connecting relationships that vector search alone can't handle. Fine-tuning takes the opposite approach. Think of it as a closed-book exam. The model must internalize the knowledge before test day. During fine-tuning, teams continue training the model on domain-specific data. This adjusts the model's internal weights, its neural network parameters, to bake in patterns from that domain. The result? The model doesn't need to look anything up. It can generate domain-specific responses from memory, following the organization's writing style, using their terminology, and respecting their constraints. Fine-tuning excels at 3 things: style adaptation, teaching the model to write like a brand; structured outputs, generating JSON, SQL, or formatted responses consistently; and task specialization, like classification or sentiment analysis, where retrieval isn't needed. But here's the trade-off. Knowledge is frozen at training time. Update the data, the model needs to be fine-tuned again. Until recently, fine-tuning large models required massive compute resources. In 2022, fine-tuning a 65 billion parameter model cost around $50,000 and required 8 A100 GPUs. Then came QLoRA, quantized low-rank adaptation. Published in May 2023, it was a genuine breakthrough. QLoRA does 2 clever things. First, it freezes the base model and only trains small adapter layers, less than 1% of parameters. Second, it quantizes the frozen model to 4-bit precision, dramatically reducing memory. The result? A model requiring 780 gigabytes of memory now fits in 48 gigabytes. That's a single consumer GPU. Cost dropped from $50,000 to around $1,500, a 97% reduction. This democratized fine-tuning. Virgin Voyage's creative team, non-technical marketers, used QLoRA to build 50 AI agents. Campaign creation time dropped by 40%. Sales increased 28% year over year. QLoRA is part of the broader parametric efficient fine-tuning, or PEFT, movement. Methods like IA3, which rescales activations, and prompt tuning update less than 1% of parameters while matching full fine-tuning performance. It's not just about cost, it's about making fine-tuning accessible. What if enterprises could combine the best of both worlds? That's exactly what researchers at UC Berkeley asked in March 2024. RAFT, Retrieval Augmented Fine-Tuning, does something counterintuitive. Instead of choosing between RAG or fine-tuning, it fine-tunes the model to be better at RAG. Here's the insight. During training, the model sees questions, correct answers, and relevant documents and distractor documents. It learns to identify what's useful and ignore what's not, even when both look relevant. The results surprised even the researchers. RAFT fine-tuned Llama 2 7B outperformed larger models with standard RAG. On Hotpot QA, a 30.87% improvement. On Torch Hub documentation, a 76.35% improvement. And here's the surprising part. Training with 80% Oracle documents plus 20% without documents performed better than training with 100% Oracle documents. Teaching the model to handle imperfect retrieval made it more robust. This is the future. RAG handles dynamic knowledge. Fine-tuning teaches the model how to use that knowledge effectively. Together, they're stronger than either approach alone. So what are the key learnings for 2025? First, the economics shifted. QLoRA dropped fine-tuning costs by 97%. Long context windows reduced retrieval needs. What was expensive became accessible. Second, start simple. Don't architect for complexity on day one. Begin with RAG for knowledge. Add fine-tuning for consistent style. Scale to hybrid approaches and agents as requirements demanded. Third, user experience is the primary driver of successful AI adoption. The most sophisticated system fails if people don't use it. Prioritize speed, simplicity, and trust. And here's the pattern. Winners aren't choosing one technique. They're orchestrating capabilities to match specific needs. The playbook? RAG for knowledge retrieval, hybrid approaches for accuracy, fine-tuning for consistent behavior, and agents for orchestrating workflows. If you found this helpful, subscribe to the channel for more deep dives into AI infrastructure and technology explained.